So the learning objective for this video is to analyze the acceleration of an object. Now, obviously, before we do that, we really need to define what acceleration is. So, acceleration is a measurement of how fast an object's velocity changes. So if an object's velocity changes in any way, we have an acceleration. So it is a rate of change of velocity. So being that it's a rate means that it's going to be change in velocity over a change in time. Now, obviously this is going to be an average because it's over a period of time. Now if we've got velocity now in meters per second and we're looking at this as a rate of change of velocity, it's going to be meters per second every second. So it's now we've got 2 seconds inverted, which now become ms to the power of minus 2. So that is our unit, meters per second for acceleration, and that's how we write it. Now this formula gets abbreviated down to A average. Sometimes it's just written as A over a change in V, which equals a change in V over a change in T, where the delta symbol there, the little triangle, that's a capital Greek D, means change in. Sometimes it's just left as V over T, but it's definitely makes a lot more sense to be saying delta V, because obviously it's not just a velocity, so it'd actually be a bit incorrect if you saw it written that way. What's more commonly seen is it written as A equals final velocity minus initial velocity over T, and we've seen V and U previously. Now this equation is often also rearranged, and you can do that yourself, you don't need to memorize both of these, as V equals U plus AT. It's the exact same equation where we've made the final velocity the subject, and this is sometimes useful because you often get questions associated with acceleration that involve finding the final time. So that's a useful one to save you the time rearranging it. You just quickly remember V equals U plus AT, or VUAT. So now what we want to do is take a little look at how direction affects acceleration. What we need to really get our heads around in kinematics, it's probably one of the hardest parts, is acceleration and its direction. So let's talk about this in sort of layman's terms, where we would really just sort of talk about speeds and we talk about accelerating and decelerating. So I'm just going to walk down the end and walk back, and we'll talk about how my speed changes. So as my speed increases, we would normally say I'm accelerating. I've got a constant speed now, and now I'm decelerating as I slow down. I've come to a stop, so I have 0 acceleration, and now I'm accelerating again as my speed increases. Constant velocity, so there's 0 acceleration, and now I slow down, which is what we would call decelerating. Now, we need to stop using this language of decelerating. We need to start talking about this in terms of positive and negative acceleration, and that gives us a direction. So I'm going to say going forward is my positive direction, and going towards the camera is my negative direction. So we need to talk about this in terms of what is our velocity doing, in what direction is our velocity changing. So as I start to increase my velocity, I have positive acceleration. I'm walking, and as I start to slow my velocity is increasing in this direction, the other direction, so it's negative. So I now say I've got negative acceleration. I stop, 0 acceleration. As I increase my velocity in the negative direction, I've now got negative acceleration. Constant velocity, so 0 acceleration. Now as I slow down, my velocity is increasing in the positive direction. So I have positive acceleration. So I'm just going to do this one more time. So we have positive acceleration, 0 acceleration, negative acceleration, 0 acceleration, negative acceleration, 0 acceleration, positive acceleration, 0 acceleration. Okay, so now let's just reiterate this. So we've got in green here, going forward is a positive direction, going the opposite direction in red is a negative direction. So if we have an increasing positive velocity, the change in velocity is positive. Therefore, we have a positive acceleration. If we now have a decreasing positive velocity, the change in velocity is negative, which tells us that we have a negative acceleration. Now if we turn around and we have an increasing negative velocity, our change in velocity is negative, so the acceleration is negative. If we now have a decreasing negative velocity, the change in velocity is positive. Therefore, we have a positive acceleration. So I hope that helps you a little bit with understanding direction associated with acceleration, but I think sometimes it takes a little while, especially once you do a couple of practice questions, you get the idea of what this means. So let's have a look now at our first example. This is a very simple example and you'll see what I mean. A car traveling at 20 meters per second applies its brakes for 6 seconds. After this period, the car is traveling at 14 meters per second. Calculate the acceleration. Right, so very simply, it wants acceleration, so I'm just going to use the acceleration formula. I'm going to substitute the values where 14 is the final velocity and 20 is the initial velocity, time is 6. Gives me a value of -1 meters per second per second. Now it's negative, obviously, because this acceleration was in the opposite direction to the motion. And we assume, in a question like this, we can just assume the direction of motion is positive and anything in the opposite direction will be negative. Let's have another look at another example where we might need to use the Vuad equation. So a rocket during its launch accelerates uniformly at 25 meters per second to a maximum velocity after 4 seconds. Calculate its maximum velocity. Now, it might feel like we're not actually given a lot of information here, or not enough information, but there's hidden information in the question, and physics questions like to do this. So, for instance, we know that a rocket, when it launches, has an initial velocity of 0. So now you've probably got enough information if you can deduce from that that you have an initial velocity. So I'm going to use my Vuad equation here, and I'm substituting in my values here, so it actually becomes a very simple equation which you could do in your head. 25 times 4 gives us 100 meters per second is the final velocity v. Now there is a vast way that these questions can be asked, and you'll see that in your quiz coming up. Before we do that, I want to quickly just bring you back to this definition of acceleration, which tells us that it is a change in velocity over time. So we do have examples now where we can change the velocity but not the speed, and this is inherent in the definition. The definition does not say that acceleration is a change in speed. So the classic example here is the satellite. You can see that a satellite maintains a constant speed. It needs to do that to stay in orbit, but because it's constantly changing direction as it rotates in circular motion, its velocity is constantly changing because velocity has direction. So it's actually accelerating towards the Earth, to the center of the Earth. That's the direction it's accelerating to. But you can see it's maintaining its speed. So when an object is in circular motion and turning, it can maintain a speed, but its velocity is constantly changing, so it is accelerating. So I'm going to leave you with that note that you can have acceleration and a constant speed, but the velocity will be changing. So I hope you've got a better understanding now of acceleration, and I hope you don't have any issues with these quiz questions. If you do, please ask your teachers.